Students, so today we'll be solving exercise 13.1 and this exercise is based on to find the areas for combination of solids. Okay, let's go to the first sum. It says that two cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. So as soon as when you read the question, I will ask you, request you to draw the diagram so that you can really visualize it and then you can really make out. Okay, drawing the diagram is not compulsory, but it will give the confidence that we are going the right path. So here you can see I have joined one cube, I have drawn one more cube and they join. So two cubes are joined together and volume of each cube is given as 64. Okay, you have to find the surface area. Now we all know that volume of the cube formula is side cube. So can we find the side? It's a cube. So can we find the side here? Because length, breadth and height are same. So first thing, let us find what is side. Once we find the side of the cube, then here we have to find the surface area of the resulting cuboid. So when two cubes are joined, we get a cuboid. Okay, and for a cuboid, we know the formula is, what is the formula for surface area? Total surface area of a cuboid, 2 into L into B plus BH plus LH. So for that we require L, and you can find very clearly when two cubes are joined, the L has changed. So suppose I get my A, first I'll find A, so L will become 2A, breadth will remain the same, it is A, height will also remain the same. So there is a change in the length. Okay, so we have to find what is length, breadth and height, and then we can find TSA of the cuboid. So let's start doing. So here's solution. So first we will find the side of the cube. So when you find the solution here, volume of a cube is given as 64 centimeter cube. And what is the formula for a volume of a cube? Side cube. Therefore, here I'll write A cube equals to 64. Now we all know that cube root of 64 is nothing but 4. That means here I know that this can be written as 4 cube. So taking cube root on both the sides, if I take cube root on both the sides, I can find what is A, that is side. So therefore A equals to 4 centimeter. This means side is 4 centimeter. So once we get side, that is our A, we got A, this is 4 centimeter. So here I got this is 4 centimeter. This is also 4 centimeter. So the length has changed. So for the resulting cuboid, the length is 8. Breadth is 4 and height is also 4. So here we write, therefore, here we can write when two cubes when joined, they form cuboid. They form cuboid, correct? Therefore, we can write L is nothing but 4 plus 4, that is 8 centimeter. Breadth is nothing but no change, 4 centimeter. Height is 4. So can we find the TSA? Here they are saying surface area. So when surface area, they have not mentioned whether it is total or LSA. Surface area, if they have not mentioned, it simply means TSA. Therefore, TSA equals to, I write the formula 2 into LB plus BH plus HF. So can we write here 2 into, what is L here? 8 into B. What is B here? 4 plus what is B into H? That is 4 into 4 plus H into L. So 4 into 8. So it's a simple calculation 2. Here we get 32 plus 16 plus 32. So here we have 2. So 4, 8, 9, 10. I'm adding the units place 1, 4, 5 and 8. So I have 80. I hope I'm right. Let's check 1, 6 plus 2, 8, 9, 10, 1, 4, 5, 8. This is 80. This is 160. It is total surface area. So here we have centimeter square. At the last, don't forget to write the answer. Therefore, the surface area of the resulting cuboid is 160 centimeter square. Correct? Yes, coming to exercise 13.1 second sum. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So whenever we read the question, you should read bit by bit and try to understand. As I already said, let's go for drawing the diagram to get a clear picture. Let's learn again. Let's read again. A vessel, there is a vessel. Now what is the form of the vessel? It is in the form of a hollow hemisphere. So let's draw a hemisphere. So check out. Okay, I'll draw a little here. Okay, so here I'll draw a hemisphere. So, okay, hollow hemisphere. Now this is mounted means something is kept. What is that? By a hollow cylinder. So it is kept by a hollow cylinder. Can you see this? So here we have, now this should remind you of one vessel. Can you see that? So see the diagram here. Cylinder is mounted on a hemisphere. Okay, so this looks like a test tube. You must have seen a test tube also. You can see a cylinder and a hemisphere. Let's try to analyze what is given. So a vessel is in the form. So our vessel means now it is in the form of cylinder and hemisphere. So when you think about your vessel, it should be one figure. This is the one whole thing which is cylinder at the top and hemisphere at the bottom, like a test tube. Test tube is one vessel, one object, correct? Now here it is given that it is in the form of hollow hemisphere mounted by a hollow cylinder. Now it is given the diameter of the hemisphere. So this diameter is given as 14 centimeter. Diameter is given as 14 centimeter. And the total height of the vessel. So total height of the vessel, it means that from here to here, the total height is given as 13 centimeter. This is a 13 centimeter. Find the inner surface area of the vessel. So you have to find out the inner surface area of the vessel. Now since this vessel is made up of two objects, as we are learning combination, that is cylinder and hemisphere. So we will find the surface area of cylinder and the surface area of the hemisphere. So here the surface area, here we know it's a hollow cylinder. So we don't have a, here it is open, and down also it is one object. It is one object, okay. It is one object like a test tube. So here you can find here the cylinder, here also, here it is continuation with a hemisphere. So till here if it is a cylinder, here it is an hemisphere. So again it is open. So here we have to find the CSA of the cylinder and the CSA of the hemisphere. Okay, for CSA of the cylinder formula is 2 pi RH. Let's see, we have for cylinder, we know R, the radius of the hemisphere and the radius of the cylinder are same. What about height? Here the total height is given. So height of the cylinder particularly is not given. Can we find the height of this cylinder? Yes. Here we know that here the diameter is 14. So the radius is 7. So here we know this is also radius is 7. If the radius is 7, here we know the height is also 7. The radius and the height of the hemisphere will be the same. Why? Because you all know the sphere is equidistant from the center, it is equidistant. So here we said the height is same as the radius. So this height. So this much is 7 centimeter, we know. From here to here it is 7 centimeter. So can we find the height of the cylinder particularly? 13 minus 7, which will give you 6 centimeter. This is the height of the cylinder. Okay, so 2 pi RH, we can find the height, this CSA of the cylinder. We can find the CSA of the hemisphere, and then when you add, we can find the total. We can find the total CSA of the vessel. Correct? So let's start doing here. So here solution. So when we write here, first we will write for cylinder. That is here what they are given. Diameter total is given. So let's write for cylinder first. So for cylinder, students, what is R? R is nothing but they are same. R is same for both. So R is nothing but 14 upon 2, that is 7 centimeter. R is same. The height H, let's see, H is nothing but 13 minus 7, that is 13 minus 7, that is 6 centimeter. So R and H is known. For sphere, that is for hemisphere, R is the same. So for hemisphere also, we have R equals to 7 centimeters. So just we can write the data for cylinder, what is R and H. Here we have mentioned same R because the radius is same. Suppose we have different, then we have to mention R, R1, R1, R2, anything. So here, so let's find here. So when we write here, let's find. So here we know that the total inner surface area of vessel is nothing but is nothing but CSA of cylinder plus CSA of hemisphere. So I have not finding separately, we can do together because hardly it is for 2 markers. So CSA of cylinder plus TSA of hemisphere. So this is nothing but 2 pi RH plus here we have CSA of hemisphere is nothing but 2 pi R square. CSA of sphere is 4 pi R square, so here 2 pi R square. Can I take common? Very easily 2 pi R is common, you can see 2 pi R, 2 pi R. So here we get H plus R. Can we take multiply? So pi value is 22 by 7. Here R. What is R here? 7. What is H plus R? What is H here? H is the height of the cylinder. So 6 plus 7. So here, can you see this 7, 7 cancel? 7, 7 cancel. Here we get 44 into 13. So let's multiply 44 into 13. So here we have 3 4s are 13 4s is 52. So 2 5 13 4s are 52. 52 plus 5 is 50. That is 572. So 572 centimeters square. So this is the total surface area of the inner vessel. Yes, we start with the next fourth sum, that is surface area volume. The sum is a cuboidal block of side 7 cm is surmounted by hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the. Okay, so according to this sum, as I read, a cuboidal block of side 7 cm surmounted by a hemisphere. Now, at present to show you all, this is not a cubical block, it is actually a cuboidal block. Okay, it's a cuboid, but you just imagine that it is a cube, and this I have just taken this katori, this bowl as a hemisphere. So when I am surmounting it, just see this. Students, I'll just use this. See, if I am surmounting this by hemisphere, that means now I am just showing you the top view of this so that you understand. So from the top view, you understand that here what they have asked, that what is the greatest diameter it can have. So when I am surmounting it, you can see here, exactly here, it touches. Can you see that the ends of the bowl are touching the sides of the cube? So if I want to find the greatest diameter the hemisphere can have, what is it the greatest diameter it can have? It is same as, just see this length and this length will be the same. So the greatest diameter the hemisphere can have is nothing but the side of the cubical block. So the first answer, the greatest diameter it can have, it is nothing but 7 cm. Now to find the surface area of the solid, since it is a combination of the solid, whenever the word surface area comes, I will suggest you just think that this is one object and I am to paint it. So if I want to paint it here, this, we know that it's a combination of a cube and a hemisphere. This is a cuboid, but now I'll say this is a cube. So cube and a hemisphere. So if I want to paint this, I know that the surface area of a cube is nothing but 6a square. The total surface area of the cube is 6a square. And what about this? So you will say, but this is not covered. Yes, you are very right. This is not covered. So here we know this is a square, a square, a square, a square, 5a square is covered. But I am saying 6a square. Out of the 6a square, this much portion is not being painted. Can you see? This circle has been not painted. So this circle which is not painted, I have to remove that. Okay. So that what I have removed, that is in the form of a circle. The formula is pi r square because it is not painted. Now this is one object. What I am going to paint? This katori, this hemisphere I am going to paint. What is the surface area CSA of hemisphere? 2 pi r square. So here, so when I subtract it, so here, see, when I kept this hemisphere, you can find that this portion is there. The 4 edges, can you find it's like a sector? 4 sectors, so 4 small sectors are found at the 4 corners. So this 4 sectors, I need to paint it, right? So this is a part of that one surface area, that is a one plane surface area of the cube that I need to paint it, right? So I'll take 6a square, that is the total surface area of the cube, minus this pi r square, that is this which has been not been painted, this part is not painted, but I am painting this pi r square, that is the surface area of the hemisphere, that is 2 pi r square. So it's the hemisphere Okay, so this will give you the total surface area of the solid. Again I repeat, to find the TSA, just imagine the area means you have to paint. So which are the surface area what we come into contact? First is we will just imagine that we are painting the whole thing, that is TSA of the cube is nothing but 6a square, because this portion is there. So which has not been painted from the one surface, this circle. So I'll subtract, and what I have to add? I have to add the CSA of the hemisphere. So let's jot it down here, students. So when you write here solution here, the first thing they are asking, that is the side of the cubical block. The side of the cubical block is given as 7 centimeter. Side of the cubical block is 7 centimeter. Therefore, greatest diameter, write the answer that they have asked. Greatest diameter the hemisphere can have. The hemisphere can have, as I showed you right now, it is nothing but equal to the side of cubical block. Side of cubical block, and that is nothing but 7 centimeter. So the first answer is finished. We have to find the surface area of the solid. So therefore, surface area of solid is nothing but, as I said, first we'll consider TSA of the cube. We need to subtract, as I said, here we need to subtract this pi r square, because TSA, this circle has not been painted. Okay, so minus area of circle we are subtracting, and we are adding the CSA of hemisphere. So this is the formula, right? I hope this is understood very clearly. Correct? So here again I am explaining, when I am painting, these 4 sectors are there which to be maintained, which need to be painted, right? So we are considering the TSA minus the pi r square, and here this is nothing but 2 pi r square, correct? So when we take here, so we will get here, there is 6a square minus area of circle pi r square, and plus here 2 pi r square is the CSA of hemisphere. So 2 pi r square minus pi r square will give you pi r square, and here we can substitute 6 into a square. A is nothing but the side of the cube, that is 7 into 7. Here plus pi r square. So pi we can substitute the value 22 by 7 into, now what is the radius? This is the side of, this is the diameter. If the diameter is 7, so radius will be, so here we need to write one sentence. I'll just add here. Therefore, radius r equals to 7 upon 2. Okay, this will be more clear. So here we have 2 into, okay, I forgot 2. Good, I remember here. So here we have 2 into 22 by 7 into 7 upon 2 into 7 upon 2. So let's cancel here. 7 cancel, 2 cancel. So students, we are left with here 42 into 7. Okay, here we'll have 22 into 7, that is 154 upon 2. So here we have 7 2s are 14, 28, 29, 294. Here we can subtract 2 7s are 14. So 14 2 7s are 14. So 77, correct? So when you add here, we get 11, 15, 16, 17, 371. I hope this is correct. 294 plus 77. So 11, 16, 15, 16, 17, 371. Okay, so here we have taken pi value. So I hope we have substituted correctly. Here A is the side of the cube. 7 upon 2 we have taken, 42 into 7 this. So this is very, very important, which the students get confused how you get. I hope you have understood. Thank you. So here I think I have taken here 2 wrongly. I am really sorry, students. Here I should have taken, it is, so this is the reason where we should not skip this step. See, 6a square, 2 pi r square minus pi r square is actually plus pi r square. So here gadbad we did. So 22 by 7 into 7 upon 2 into 7 upon 2, correct? So here 7 cancel, 2 11s are, so we get 77 upon 2. Okay, so here we have 2 3s are 6. So here 6 1 2, here 17, 2 9s are 18, no, 2 6s are 2 8s are 16, so 38.5. Correct? I hope I'm right. So I'm adding here, so we'll get 0.5. 8 plus 4, 12. Here 12, 13. So here 3. So I think 332.5 and the unit is centimeter square. Finally is this. So once I say thank you, I just overlooked here. See, plus 2 pi r square minus pi r square. So the moral of the story, never skip the steps. Okay. So thank you. I hope you have understood this.